Okay, now there are some conditions imposed on these transformations, and the first condition is that the Jacobian of Q1 tilde, P1 tilde, Q2 tilde, P2 tilde, Qn tilde, Pn tilde with respect to Q1, P1, Q2, P2, Qn, Pn should be non-zero. Means the Jacobian of new coordinates with respect to the old coordinates should be non-zero. And such a transformation is termed as canonical if it carries the Hamiltonian system into the corresponding Hamiltonian system. Means if the Hamilton canonical equations in previous coordinates dqi by dt is equal to curly h by curly pi, dpi by dt is equal to minus curly h by curly qi, these are transferred into another Hamiltonian system, dqi tilde by dt is equal to curly h tilde by curly pi tilde, and dpi tilde by dt is equal to minus curly h tilde by curly qi tilde. I request you people to mark the notations for the new coordinates in equation 1 and 2. This is qi tilde, pi tilde. In equation 3, all the parts in the numerator, all the variables in the numerator will have tilde sign with them. And then equation number 5, all the coordinates as well as the function h will be marked with the tilde sign. Okay, so the transformation is said to be canonical if number 1, the Jacobian of new coordinates with respect to the old coordinates should be non-zero, and the Hamilton canonical equation should be transferred into Hamilton canonical equations. Is the parameter, sorry, and in equation 5, h tilde is the another Hamiltonian function. Okay, in these remarks it is discussed that why these transformations are important, because many times we will find out that the system of equations is not so easy to solve. Then we will use the canonical transformation and move to a new system, and in that system with the help of the Hamiltonian function which is having a simple structure or simple expression, the equations obtained will be easy to solve, and these two systems will be equivalent. So we will work in that system in which the work is easy to perform. Okay, further the canonical transformations are sometimes known as contact transformations. Now in this result it is stated that the collection of all canonical transformations is a group. All of we know that the collection of all the transformations is a group. So here we are to prove that the collection of all the canonical transformations is a group. So the only need is to prove that this set is closed with respect to whatever the operation, the composition of mappings. And since the Jacobian of, if we are assuming a qi tilde, pi tilde and qi double tilde, pi double tilde, two transformations, then all of we know that composition of two transformations is again a transformation. Further, the first equations are transferred into the next one, and then the next one are transferred into the next canonical equations. So the canonical equations are still transferred into the canonical equations. Hence, and if Jacobian of the first canonical first transformation with respect to the variables is non-zero, Jacobian of second with respect to the variables is non-zero, so their product will be non-zero, and hence we can conclude that the collection of canonical transformations is a group. Now we are having an example in which qi pi are the variables, and we are assuming that qi tilde is equal to alpha qi and pi tilde is beta pi, and h tilde is alpha beta h. Now this is a canonical transformation. Why? Because if we will find out the Jacobian of qi tilde pi tilde with respect to qi pi, then it will be something like alpha beta alpha beta alpha beta on the diagonal, and rest terms will be 0. Just imagine q1 is alpha q1, q2 is alpha q2, q3 tilde is alpha q3, and qn tilde is alpha qn. Then p1 tilde is beta p1, p2 tilde is beta p2, and pn tilde is beta pn. Now find out the Jacobian, because q1 tilde is a function of q1 only. So partial derivative of q1 tilde with respect to q1 will be alpha, and with respect to other variables will be 0. So in the first row, the first entry is alpha and rest are 0. After that, in the second row, the first term will be a partial derivative of p1 tilde with respect to q1, that will be 0. The second term will be partial derivative of p1 tilde with respect to p1, that will be beta, and rest terms will be 0. So on the diagonal, we will have alpha beta alpha beta alpha beta n times, and rest entries are 0. So determinant of such a matrix will be the product of diagonal elements, that will be alpha n beta n, and it is non-zero. Further, the Hamilton canonical equations will be transferred into Hamilton canonical equations. Why? Because on the left hand side we will have dqi tilde by dt, so it will be alpha dqi by dt. On the right hand side we will have curly h tilde by curly pi, but h tilde is alpha beta h, and pi tilde is beta pi, so beta is cancelled, and it will be alpha into curly h by curly pi. Alpha is cancelled from both sides, so we are having dqi by dt is equal to curly h by curly pi. It means the previous canonical equations. So this mapping is a canonical transformation. However, I had shared a Word file with some of you people. Sorry, not Word file. Some notes. Those are handwritten notes. So I will share those notes on the Google Classroom also, so that you will be able to get that how these are proved. Okay. The next one. In this, qi tilde is taken to be beta pi, and pi tilde is taken to be alpha qi. And then h tilde, the new Hamiltonian function, is minus alpha beta h. This is also a canonical transformation. You can try it using the simplest that we have discussed in the previous example. Now there is a result that a necessary and sufficient condition for a transformation qi tilde is equal to qi t qk pk, and pi tilde is pi tilde t qk pk, with the condition that Jacobian should be non-zero, is canonical, is the existence of a generating function f and a constant c, such that summation I from 1 to n pi delta qi minus h delta t. This is the Poincare-Cartan integral invariant, the coefficient. It should be equal to, on left hand side it is pi tilde delta qi tilde minus h tilde delta t, should be equal to c into summation I from 1 to n pi delta qi minus h delta t and minus delta f. So this is the relation between old and new variables. Here the constant c is known as the valence of the canonical transformation, and if c is 1, then the transformation is assumed known as univalent canonical transformation. Further, f, the generating function, it's a function of t, qi and pi. So its variation will be summation I from 1 to n partial derivative of f with respect to qi into del qi plus partial derivative of f with respect to pi into delta pi plus partial derivative of f with respect to t into delta t. And now replace these values in star, and then compare the coefficients of del qi, del t and del pi on both hand sides. So on left hand side, the coefficient of delta pi is pi tilde. But that on the right hand side will be cpi and then curly f by curly qi. Similarly, the coefficient of del pi is curly f by curly pi, it will be 0. And then the coefficient of delta t, on left hand side it is h tilde, on right hand side it is c minus ch and plus curly f by curly t. These will be used later on. I'm just a second, students. Let me check whether I'm having one more PDF. Okay, free canonical transformation. A transformation is said to be free if the Jacobian of q1 tilde, q2 tilde, qn tilde with respect to q1, q2, qn should be non-zero. Transformation is canonical. All other terms or conditions hold. If one more condition in addition, and with that condition is that Jacobian of q1 tilde, q2 tilde, qn tilde with respect to q1, q2, qn is non-zero. It holds. Then we will say that the transformation is free canonical transformation. Now, it is stated here that we have discussed that replacing f in star, then variation. Basically, what happens here, we are assuming that this t, q1, q2, qn and q1 tilde, q2 tilde, qn tilde, these are independent quantities. So we can express P1, P2, Pn in terms of Q1 tilde, Q2 tilde, Qn tilde, and then replacing P1, P2, Pn in F. Now the expression will be a function of T, Q1, Q2, Qn, and then Q1 tilde, Q2 tilde, Qn tilde. So the new expression will exist. We are representing that with S. So S is a function of T, Qi, and Qi tilde. And now variation of F will be variation of S. And variation of S will be summation I from 1 to n curly s by curly qi del qi plus curly s by curly qi tilde del qi tilde plus curly s by curly t delta t. Now replacing this value in star again, we will obtain equation number 3, 4 and 5 by comparing the coefficients. That curly s by curly qi will be equal to pi, curly s by curly qi tilde will be pi tilde, and h tilde will be h plus curly s by curly t. Okay, one more example is there for canonical transformation, and it is free also. Now let's obtain the Hamilton-Jacobi equation. Basically, we are not going to obtain a new equation. Rather, the equations obtained in 3, 4, 5 are known as Hamilton-Jacobi equations. It is again discussed that a holonomic system is given whose motion obeys the canonical equations of Hamilton. Okay, so we will try to find out a univalent canonical transformation such that the new variables will also satisfy the Hamilton canonical equations, and with the condition that the new function h tilde will be the zero function, so that this dqi by dt will be 0 and dpi by dt will be 0 tildes, so that the new coordinates will be the constant coefficients. Okay, so the new coordinates qi tilde will be alpha I, pi tilde will be beta I. This will be the new 2n coordinates. And knowing such a relation will help us in finding the motion and all possible solutions. So just a similar discussion that we have replaced pi with the appropriate expressions in terms of qi tildes, and so the generating function f will have a new expression represented with s, a function of t, qi and qi tilde, and then using the remark we will have h tilde will be equal to h plus curly s by curly t, curly s by curly qi will be pi, and curly s by curly qi tilde will be minus pi. So from here h tilde is 0. So equation number 8 will be written like curly s by curly t plus h. H is a function of t, qi and pi. So pi is replaced. So h is a function of t, qi, curly s by curly qi equal to 0. And now this equation 10 is known as the Hamilton-Jacobi. Okay. Here it is assumed that the Hessian should be non-zero because we are going to find out the expressions. So using the Jacobians and Hessians, we obtained that all the possible expressions. Okay. Now the complete integral, the solution of the Hamilton-Jacobi equation containing all the n arbitrary constants is known as the complete integral. Okay. Further, there is the Jacobi theorem that if S is some complete integral of the Hamilton-Jacobi equation, then it will satisfy these equations. We have obtained these equations in the remark, so it is easy to derive these. After that, conservative system is given, means the system is made independent of t, and so the equation will be curly s by curly t plus h. This time h is independent of t, so it will be qi curly s by curly qi equal to 0. Further, while obtaining the Whittaker equations, we discussed that if h is independent of t, then it will be a constant function. So from equation 1, replace h in equation 2. We will have equation number 4, curly s by curly t plus h is equal to 0. Now integrating both sides, on left hand side we will have s, on right hand side it will be minus ht plus some constant. But here s is a function of t, q1, q2, qn, alpha 1, alpha 2, alpha n, and we just integrated with respect to t. So the constant will depend on the remaining variables. So s will be minus ht plus v, q1, q2, qn, alpha 1, alpha 2, alpha n. Here this v is a constant of integration. Why I am saying it is constant, however it's a function, because we integrated with respect to t. So this v does not involve t explicitly, and so it is a constant term for integration. Now replacing this value into, we obtained the expression for h also, and thus the Hamilton-Jacobi equation is obtained. Okay, so up to now that's all for today. Tomorrow we will discuss about some Poisson brackets and some more that will help us in